so let's start with the 28th example. And it is said that figure shows a circular coil. So here there is a circular coil. Its number of turns is capital N, radius is small a, connected to a battery of EMF E, and there is a rheostat. The rheostat is having a length L and resistance R. The resistance of the coil is small r. So resistance of the coil is small r in ohm. While here also there is a circular loop and a small circular loop of radius a dash, and its resistance is r dash ohm, is placed coaxially with the coil. The center of the loop is at a distance x. So the center of the loop is at a distance x from the center of coil. In the beginning, the sliding contact is at the left end. So in the beginning, as the sliding contact is at the left end, it means the complete resistance is there in contact with the coil. Okay. While and the contact is being moved towards right with speed v meter per second and with speed b. So the EMF induced in the smaller coil loop at the instant when contacts begin to slide and has slid through the length. Okay, so no problem. So it is being moving here. So first of all, we will calculate the mutual inductance between these two, the setup. So the flux link with the loop will be number of turns of the loop into area of the loop into magnetic field produced by the coil. Number of turns of the loop, so it's a single loop, there is no turn. Area of the loop will be pi a dash square, while magnetic field produced by the coil at axial distance x is given by mu naught ni radius square, that is a square, upon 2 bracket square of the radius square of the axial distance raised to 3/2. Okay, that's the flux. So the flux link with the loop will be mu naught pi n a dash square I upon 2 in bracket a square plus x square raised to 3/2. Well, we know that this particular portion is nothing but the mutual inductance between the two coils. Okay. Now this particular thing is moving here like this. So resistance is decreasing. In the circuit, the resistance is decreasing, so obviously current is also decreasing. So let us suppose when it is moved by a distance x towards right, say y, because x is already there in the question. So for any distance y it is being moved, so resistance would be, so for length L the resistance is R. So for L minus y, what would be the resistance? So resistance will be R in bracket L minus y upon L. So it will be R in bracket 1 minus y upon 1 minus y by L. 1 minus y by L. Okay. And we know that the current in the circuit, so current in the circuit at any instant will be given by EMF upon resistance. So it will be resistance of the circular coil plus resistance of the rheostat wire in contact, I minus this thing. Okay, and the current is changing. We know that in mutual inductance, the EMF induced in the loop will be mutual inductance into di by dt. So it will be the mutual inductance we have already calculated. In the later part we will substitute the value, and it will be the derivative of E upon R plus R in bracket 1 minus y by L, like this. So the EMF induced in the loop would be M into E into 1 upon this portion. So the derivative of the 1 upon this portion will be minus 1 upon the whole square of this part, R in bracket 1 minus y by L. Okay, or I will multiply this before differentiating. I will multiply this. That would become easier to differentiate. So it will be d by dt in bracket 1 upon r plus r minus y into r by L. So it will be m into e into minus 1 upon this whole square r plus r minus yr by L the whole square into coefficient of L y minus r by L into derivative of y dy by dt. We know that how y is changing with time, that is nothing but the speed. So EMF induced in the loop at any instant is given by mutual inductance into E into R, this is V, upon L in bracket small r plus capital R minus Ry upon L the whole square. And now I will just substitute the value of y because y is the only variable. Start when the contact begin to slide. So starting from the left end, when it is begin to slide, total resistance is there and the y length traveled is 0. So in the first case the y is 0. So EMF induced in the loop would be MERV upon L in bracket small r plus capital R minus 0. So I will substitute the value of mutual inductance, that is from above, which is mu naught pi n a dash square mu dash pi n a dash square a square upon 2 in bracket a square plus x square e r v as it is L in bracket r plus r. Second, when it is half the length, so y is equal to L by 2. So I can write the EMF induced in the loop would be MERV upon L in bracket r plus r minus r by L into L by 2 whole square. So it will be, here this is the square that we are forgetting to write, MERV upon L in bracket r plus r by 2 whole square, and on substituting the value of m and arranging this we will get the required answer. Thank you.